Hello friends, today we are going to derive all the trigonometric identities. In the previous video we have derived one trigonometric identity, and with the help of that identity we are going to derive rest of the trigonometric identities. If you have not watched the previous video, please make sure to watch, because in that video we have derived sin A plus B, and with the help of that trigonometric identity we will derive other most important remaining trigonometric identity. So before we go for the derivation, we have to know about the relation between trigonometric ratios in positive and negative angles. Okay, for that we'll take a one unit circle. So unit circle is circle with radius r equals to 1 unit. Okay, that means radius with 1 unit. We'll construct a one right triangle here, and let's measure this angle in counterclockwise. So always this is positive angle. Okay, when we measure angle in counterclockwise, so the angle we take is positive, and this distance, let's say P, and this is B. Okay, this is B, base, and this is perpendicular distance, perpendicular side of this angle. Similarly, let's draw a triangle with the same measurement. Okay, that means minus P. Since I'm measuring this along a negative y-axis, this side negative y-axis, so this is minus P, and base will be same, and the hypotenuse will be 1 unit, because this is the radius of a unit circle. So let's give a name A, B, C and D. So we will take two cases. First is in right triangle ABC, this triangle. Okay, ABC, we'll see the value of sin theta, positive angle, sin theta, cos theta and tan theta. In second case, in right triangle ACD, we'll take a negative angle. Okay, cos minus theta, tan minus theta. So this triangle. Okay, now if you take a right triangle ABC, this triangle, you'll get sin theta equals to opposite P by hypotenuse 1. That means P. Cos theta will be base by hypotenuse 1, so no need to write 1, and tan theta is similarly opposite by base. So in right triangle ACD, this triangle, so we'll measure this as a minus theta. Okay, clockwise. Whenever we measure an angle in a clockwise direction, we give angle as negative angle. Okay, so that means sin minus theta, this theta equals to opposite minus P by hypotenuse 1. That means minus P. Cos theta will be base is same by 1, and tan theta will be minus P, this opposite by base. So from here we got the value sin minus theta equals to minus the value of P here, P equals to sin theta. So if we put the value sin theta, so this is one important, and next is cos minus theta, which is equals to B. B is equals to cos theta, okay, and tan theta, tan minus theta is minus P by B. P by E is tan theta, that is minus tan theta. Okay, so if I take the reciprocal of sin minus theta, that means cosec minus theta will give me minus cosec theta. Okay, and cos reciprocal of cos is sec minus theta will give us sec theta. Similarly, reciprocal of tan theta is cot theta will give us minus cot theta. So these are very important. So as you can see that only these two identities, only these two ratios are giving the same. Cos minus theta will give me cos theta, and sec minus theta will give me sec theta, and the rest of the four ratios will change. Okay, sin minus theta will give us minus sin theta, cosec minus theta give us minus cosec theta, tan minus theta give us minus tan theta, and cot minus theta give us minus cot theta. So this is very important before we go for the derivations. So first the derivation is, again we will take a one unit circle. So we will derive a Pythagorean identities. For that we'll take a one unit circle and let's take a one right triangle, and this is theta measuring in counterclockwise. Let's say A, B and C. This is this distance as x, and let's say this is y. Okay, in right triangle ABC, this triangle, sine theta is equals to opposite y by 1. Okay, this is 1 because this is unit circle, so which is equals to y, and cos theta will give me base, that is x by 1, which is equals to x. That means this distance is sine theta and this distance is cos theta. So using Pythagoras theorem, hypotenuse is square, AB square equals to BC square plus AC square. So if you put the value of AB square is 1 square, so BC square, this BC square means y, which is equals to sine square theta plus AC is cos square theta x, which is equals to 1 equals to sine square theta plus cos square theta. So this is one identity, Pythagorean identity. Let's give 1. Next what we'll do is divide both sides by sine square theta. Okay, if you divide equation 1 both side by sine square theta, that means 1 by sine square theta equals to sine square theta plus cos square theta divided by sine square theta. So 1 by sine square theta is cosec square theta equals to sine square theta by sine square theta plus cos square theta by sine square theta. So cosec square theta equals to, this gets cancelled, 1 plus cos by sine cot square theta. So this is another identity, that is second. Now again divide both sides by cos square theta. Okay, divide this equation 1 both sides by cos square theta, you'll get 1 by cos square theta equals to sine square theta plus cos square theta divided by cos square theta. 1 by cos square theta equals to sine square theta by cos square theta plus cos square theta by cos square theta. So 1 by cos square theta is sec square theta, which is equals to sine square theta by cos square theta, tan square theta, sine by cos, tan square theta plus cancelled. Yes. So this is the third identity, Pythagorean identity. So let me write in a proper way. First we got is sine square theta plus cos square theta equals to 1. Second, 1 plus tan square theta equals to sec square theta. 1 plus cot square theta equals to cosec square theta. So this is the Pythagorean identity. So ये दो चीज़ जानना बहुत ज़रूरी था before we move for the derivations. So in the next video we will derive other very important trigonometric identities. Thank you so much for watching.